Hello everyone, welcome back. This video will learn about interfacing relay with Arduino. Relay is a very important component for our electronics project, and in this video we'll learn the basics about relay and how we can interface with Arduino. Let's get started. Relay, it is essentially an electromagnetic switch that can be controlled electronically. Relays are used to control high voltage or high current circuit with a low voltage signal, such as those signal from microcontroller or Arduino. Relays, they have two primary components. The first one is electromagnetic coil and a set of electrical contacts. And when an electric current is applied to the coil, it creates a magnetic field that causes the contacts to close or open depending on the type of relay. So this information I have just read out, these are all related to mechanical relays. But there are some other types of relays also, like we have electromagnetic relays as the basic type of relay. Then we have solid state relay. So here semiconductor switches are used for making contacts. Then we have reed relays. So here's some demonstration of the relays, how they look like. The most common one is the mechanical relay, but nowadays solid state relay is also getting popular. So let's have a look. What's the basic difference between mechanical relay and solid state relay? We'll skip reed relay in this lecture. About operating principle, mechanical relay, they are basically electromagnetic coil and physical contact based relay. But in solid state relay, there is no moving parts. All the components are semiconductor components. The reliability, mechanical contacts can wear out as the contacts moves a lot for each operation, so they can wear out. But solid state relay, there is no moving parts, hence they possess a longer lifespan and increased reliability. About speed, millisecond level switching time can be obtained from mechanical relay. Microsecond level switching time can be obtained from solid state relay or SSR. Noise, as the mechanical contact moves, there is audible clicks and EMI possible, that is electromagnetic interference possible. But solid state relay, they operate silently and there is minimal EMI. Size and weight, generally larger and heavier for the mechanical relays, whereas solid state relays are smaller and lighter. About isolation, mechanical relay, they provide excellent electrical isolation. Solid state relay, it's good but may have some limitations. About voltage and current rating, mechanical relays, these are applicable also for heavy duty applications as well as low voltage applications. But SSR, they may not match extremes. So they have also high voltage rating but not as high as the mechanical relays. Heat generation, in mechanical relays, minimum heat is generated. But in solid state relay, due to semiconductor components, there might be heat generated from those components. Arcing and contact bounce. So these are common for mechanical relays. There is possible to have arcing or bouncing. But in SSR, there is no moving contacts, hence no bouncing arcing. About environmental consideration, these mechanical relays, these are susceptible to shock and vibration. But solid state relay, they do not pose any vibration or they do not cause any shock. So these are more resistant to this phenomena. I hope you got an idea about these two type of relays we have for our projects. So mechanical relays we will be talking about in details in this lecture about this one. And solid state relay, maybe in future lecture we can refer to it. Or if you are working with solid state relay, you can refer to their datasheet or description from the internet. So here's a basic single channel relay module we have on our screen. From this picture you can see they have 6 pins. From controlling side they have 3 pins. One is for VCC, second one is for ground, and third one is for signaling. That is the output from your microcontroller will be given here, and according to the signal the relay will operate. On the output side of the relay, we have 3 pins. The first one is normally closed, the middle one is the common pin, and the last one is the normally open pin. So without the module, the relay, they have these 5 pins, 1 and 2 is for coil, 3 is for common, and these two are used for output. One is for normally open and another one is for normally closed. So these coils 1 and 2, these coils are the input for this relay, and this common NC and NO are the output for this relay. And the connection between them are like this. There is a coil, 1 and 2 is connected to this coil, and when you are working on the outside, there is a common terminal like this 3. 3 is connected to this terminal, and this is movable contact. This is connected to this one, but if there are current signal in the coil, it will swap its connection from here to here. Let me use a pen here. So this is connected to here. When it is not energized, there is no current here in the contact, but whenever we apply current through this coil, it swaps this connection to this one. So I hope you got the idea. Then this contact will break. So that's why this is called normally closed, because without energization, the common contact will be connected like this. But whenever there is a energization or there is a current supplied to the coil, it will connect in this circuit. Here's the internal structure of the relay. These two contacts are the moving contacts. So they, with accordance to the applied signal, they move. So in the market, there are several types of relay modules available. Like we have this single channel relay, we have 2-channel relay, 3-channel or 4-channel relay. If you are working on bigger project with more modules you need, then we have gang relays like 16-channel relay. So these are most available relay modules on the market. In this video, we'll work with this single channel relay in the upcoming demonstration. Okay, now that we have obtained the basic concepts of relay, now let's do some practice with relay circuit. In the first practice, we want to turn on an LED based on relay configuration or relay energization. That means whenever I press the switch with relay input, the LED connected to the output circuit will turn on. So this is the first practice we will do. Let's bring in relay module from the search of part list. So this is the relay module, and you can notice here, as mentioned as described in the slide, we have these 3 input pin and 3 output pin. Okay, so let's bring in a switch here. I'll pick this push button, then bring in VCC. I'll bring in ground, GND. For internal switching, you already know how to use push switch with Arduino or any circuit configuration. So we'll bring in a resistor for connecting as pull down resistor. Okay, so let's build the input side. I will connect it to input. First connect the VCC to here and ground to here. And switch first terminal is connected to VCC. Let's make this red color. Okay, what will happen now? Let's see. Whenever I press this button, this VCC supply will come through this switch. The switch will get closed. Then it will supply 5 volt to the input. Whenever I release the button, what will happen? The ground with the resistor through this switch will get to the input pin. And remember, the lower two are short circuited, upper two terminals are short circuited, but the upper two pin are isolated from these lower 2 pins. So this we have discussed in details in the switch video. Now let's complete the output circuit. We'll bring in an LED. You can flip the connection by pressing this button. Let's bring in VCC. We'll bring in the VCC here, then bring in a resistor for the LED, then connect a ground. Okay, so what we are planning to do here, whenever I press this button and the relay got energized, it will turn on the LED. That means the LED circuit will connect it to NO pin, that is normally open. Whenever the switch is pressed on the input side, the NO pin will get connected to common pin and the circuit will receive positive supply. So hence I am connecting the VCC to common terminal, then to the NO pin and then throw the LED and resistance to the ground. So this is a pretty simple circuit. I hope you got the idea how to configure the circuit here. Let's do the simulation. The power LED has turned on. That means it has received power. Now the coil is not energized in this moment. If I press this button, it will energize the coil and the LED will turn on. And also the output LED will receive power from this common pin. Let's do it again. Hope you got the idea. Now we'll modify this code for something better. This is practice 2. In practice 2, we'll try to make a status indicator circuit using relay. That means whenever the relay coil get energized, it will turn on a green LED. If it is not energized, then the red LED will turn on. So for that reason, we'll need 2 LED. Let's build the circuit. We'll bring in another LED here. I'll make it flip here and bring in another resistor, or you can share this resistor also. So this first LED, it will connect to NC connection, then the other terminal will go to ground through the resistor. Now what color should be connected to NO and what color should be connected to NC? We want to make a green LED turn on if the relay get energized. So for that reason, it will be green LED. And whenever the relay got de-energized, the NC connection will get active and the red LED should turn on. So let's see if it works. So I haven't pressed the switch yet. The red LED that is indicating that the power is off. If I press this button, it will turn on the green LED indicating that the power is on. If I leave it, red, green, red, green. So I hope you got the idea how to configure an relay with any external circuitry. Now the best part of this relay, we want to interface this relay with an Arduino circuit. That means this input will be given from Arduino, not from any manual input. We want to connect an Arduino circuit here. Okay, now it's practice 3. In this practice, we want to interface an Arduino module with relay, and we want to make alternative blinking with Arduino Uno. That means the Arduino will give high supply to this input once, then after a delay it will make it low. So this is the effect we want to perform in this practice. So let's modify the circuit here. We do not need the switch anymore. The resistance, we do not need it. Let's power up the relay from the Arduino supply. Okay, we need first to connect the relay VCC to our Arduino VCC. Let's connect it to 5 volt. Then we have ground. Let's connect it to ground. Okay, so the VCC and ground connection is done. Now here comes the input. We'll take pin number 2 as the input from Arduino to relay. Now let's configure the code for this circuit. First of all, we'll define the relay pin. So it's a constant pin, integer, relay pin, and as we have connected to pin number 2, so that's why we are putting 2 here. So now this 2 number pin, this is an output for this Arduino. Hence, in the pin mode, we'll define the relay pin as output. Now in void loop, we'll first make the relay energized. For that reason, we'll make it high using digital write relay pin. Then we want to make it high. After a delay of maybe 500 millisecond, we'll make it low again of 500 millisecond. So this is a pretty simple program and a simple circuit to demonstrate the interfacing with Arduino. So let's do the simulation here. So here you can see at the very first the relay get energized with green LED, and when it turns off, the red LED turn on. We haven't programmed anything for red LED here, but as the NO and NC are coupled together. That is why both LEDs are working alternatively. So I hope you got an idea how relay works, how we can connect Arduino to relay, how we can configure the internal and external circuitry, and I hope these relay based projects will help you to unleash your potential to some more extent. We basically use this relay for different types of home automation, different types of motor control, and different types of heavy load automation, etc. Remember, the relay input side, the power should be DC power, that is 5 volt. If the relay is a 5 volt relay, then we should connect a 5 volt DC supply here. But there is no restriction on the output side. The output side power could be AC, could be DC, and this will depend on the relay capacity. What is the amperage, what is the rating of the relay? You should check that out before connecting a relay to your project. Just to give you a better idea, let's notice this picture here. This is a relay, and what is it's mentioning on the top of the relay? It can carry 10 ampere 250 volt AC, or it can carry 10 ampere 30 volt DC, or it can carry 10 ampere 120 volt AC, or 10 ampere 8 volt DC. So these are its output voltage rating. And what's the input? That is the 5 volt DC. This is the input for this relay. Well, so this is how you can know what is the capacity of the relay, what is the rating of the relay. I hope you got the idea. So this is all for this video. I hope you got a pretty good idea about relay and relay modules and its working, its interfacing with different circuitry and etc. I'll see you in the next video. Thank you.